The first elementary signal of interest for us is the unit step, or also sometimes called Heaviside function, which will denote small u of t. It's 0 for all time up until 0, and then jumps to the value 1. Hence, it is defined as 1 for t greater or equal to 0, and 0 for t less than 0. The next elementary signal is the rectangular pulse, which is denoted rect of t divided by tau, where tau is the width of the pulse. The signal is 0 for times up until minus tau half, is equal to 1 for times between minus tau half and plus tau half, and 0 again for all times greater than tau half, which can be expressed mathematically as being equal to 1 for all t which are by magnitude less or equal to tau half, and 0 for all times t which by magnitude are greater than tau half. The next group of interest of elementary signals are the sinusoidal signals. For example, the sine, which has a frequency omega 0, and maybe also a phase theta. Related to the sine is the sinc function of omega 0 t, which in signal processing is defined to be sine of pi omega 0 t divided by pi omega 0 t. Drawing the sinc yields this result. The sinc is equal to 1 for t equals 0 and has a number of zero crossings. The first zero crossing is at 1 divided by omega 0. The second at 2 divided by omega 0, and so on. It also has zero crossings at minus 1 divided by omega 0, minus 2 divided by omega 0, minus 3 divided by omega 0, and so on. Exponential signals are denoted as e to the power of sigma t. If sigma is less than 0, the exponential follows this curve, where it crosses value 1 for time equals 0. For sigma greater than 0, this yields an exponentially growing signal, and sigma equal to 0 yields the constant 1. Another very important signal is the unit impulse function. Sometimes it's also called the Dirac delta, and it is denoted as delta of t. Delta t is defined to be 0 for all values of t unequal to 0 and infinity for t equal to 0, which will symbolize by an arrow pointing upwards. Delta t can be expressed as the first derivative of the unit step function, and the integral between minus infinity till infinity of delta t is defined to be 1. The signum or sine function is defined to be minus 1 for values of t less than 0, 0 for t equals 0, and plus 1 for t greater than 0. The symbol for the signum function is sgn of t, and it's defined to be plus 1 for positive values of time t, 0 for time equals 0, and minus 1 for negative values of t. The ramp function is 0 up until t equals 0, and then increases with slope 1, so that for t equals 1, it has reached value 1. This can be expressed mathematically as r of t is equal to t times the unit step, or is equal to t for t greater or equal to 0, and 0 for t less than 0.